Hi, I'm Chris Bailey from Real Python, and I want to welcome you to the course Arduino with Python. Microcontrollers have been around for a long time. They're used in everything from complex machinery to common household appliances. However, working with them has traditionally been reserved for those with formal technical training, such as technicians or electrical engineers. The emergence of the Arduino platform has made electronic application design much more accessible to all developers. And in this course, you'll discover how to use Arduino with Python to develop your own electronic projects. So what are you going to cover in this course? You learn to set up electronic circuits, learn how to set up the Fermata protocol on Arduino. You'll write some basic applications for Arduino in Python. You'll learn to control the analog and digital inputs and outputs on the Arduino. You'll learn how to integrate Arduino sensors and switches with higher level apps. And you'll practice triggering notifications on your PC and how to send emails using Arduino. Let me give you an overview of the table of contents. It starts with this course overview and introduction. Then it's going to dive into the Arduino platform, a bit about the history of Arduino and the Internet of Things and the maker movement, but also some background on electronics, how to read resistors, and how to use a breadboard. Then you'll dive right into setting up a Hello World program with Arduino and connecting it to your machine. Then you'll learn about connecting external components to the Arduino, where you'll practice using a breadboard. Then you'll remake that Hello World program using Python with the Arduino. Then you'll learn about reading the Arduino's digital inputs. After that, you get to practice reading analog inputs and using the analog outputs. Then you'll learn how you could use a sensor to trigger notifications on your PC, and how you could have it send an email. Then there'll be a conclusion and a course review. Okay, it's time to get started with some background on the Arduino platform. In this video, I'm going to give you some background on the Arduino platform and talk about the hardware and software that you'll need for this course. Arduino is an open source platform. It's composed of hardware and software that allows for rapid development of interactive electronic projects. And the emergence of Arduino drew the attention of professionals from many different industries. And that really contributed to the start of the maker movement. With the growing popularity of the maker movement and the concept of the Internet of Things, Arduino has become one of the main platforms for electronic prototyping. And it provides a great platform for creating MVPs, or minimum viable products. Arduino uses its own programming language, which is similar to C++. However, it's possible, as you'll see through this course, to use the Arduino with Python, or another high-level programming language. In fact, platforms like Arduino work well with Python, especially for applications that require integrating sensors and other physical devices. As I hope you see in this course, Arduino and Python can facilitate an effective learning environment that'll encourage developers like yourself to get a little bit more into electronic design. The Arduino platform includes both hardware and software products, and throughout this course, you'll use Arduino hardware and Python software to learn about basic circuits as well as digital and analog inputs and outputs. So what do you need? Well, the main ingredient you're going to need is an Arduino board. This is a screen grab from store.arduino.cc, but this isn't the only place that you can purchase Arduino parts and kits. You can find them from various online retailers or possibly an electronic shop in your town. A small kit can be a good option because it might include a lot of the parts that I list in the upcoming hardware requirements for this course. And here's that list. So first off, you need an Arduino board. It can be an Arduino Uno, which is what I'll be using, but it can be another compatible board. And along with that, you're going to need a standard LED of any color, one push button, a 10K ohm potentiometer, a 470 ohm resistor, and I'm going to show you a little bit about reading resistors in the next couple slides. And along with that, a 10K ohm resistor. It's not required, but it is much handier to use a breadboard for assembling electronic circuits. And then to tie things together, if you're using that breadboard, you're going to need some jumper wires of various colors and sizes. Okay, a common skill that you'll need to have is how to read resistors. So I created this chart that you can use, and it's in the accompanying PDF that you can download. And as you might have noticed when I was showing you pictures of the resistors a moment ago, they have bands of color on them. In general, the first three colors represent the value of a resistor, while the fourth color, or in some cases the fifth color, represent its tolerance. And the first one is a 4-band example. The first two colors are going to indicate the significant digits, and the third one is going to be the multiplier. So starting from the left side, you'll see that there's a brown band, which indicates a 1, then a black band, which indicates a 0, then an orange band, which is the multiplier. So in this case, it's multiplying by 1,000 ohms. The last band is the tolerance band, and it means this value is going to be within 5% plus or minus of this total value. So take the three values together, and you end up with 10K ohm, 10,000 ohms. So that's one type you need. And here's the other. You can see the first band, in this case it's a 5-band. It's starting with yellow for 4. Then it's a little hard to see. The resistor itself is blue in color, but the band is actually violet. And it's a little hard to see that, but that is the actual color, is sort of a violet. Printing of resistors, the quality of the colors can really vary. The next band is black, which is a 0. So 470 is what you're starting with for the significant digits. Then comes the multiplier. It's a black band also, times 1. So this is actually 470 ohms. The last band, which is actually brown, it's a little hard to see the brown there. I tried my best to get the colors to come out in the photograph, it's a tolerance of plus or minus 1%. So here is a 470 ohm resistor. So this will be included in the PDF that you can download along with this course. I hope this chart will help you identify your resistors. So what's a breadboard? A breadboard is a fantastic tool for putting together prototypes and connecting circuits together without the need for a soldering gun, or more importantly, a desoldering tool. Notice that there's a top and bottom section, sort of side rails, if you will, that have marked positive and negative values. The entire negative row is interconnected. So anything that you plug into one of the spots along the top will be connected to any of the other negative spots. And the same holds true for the positive row. The rows with the letters A, B, C, D, E, and the other set of F, G, H, I, J are connected only the 5 in a row together, say F1 to J1, and so forth. And I can kind of show you what that means. In fact, again, here down at the bottom, blue and red are connected again. So what's going on underneath it? Well, my breadboard, on the bottom of it, there's a piece of paper, and it can be folded back, sort of hiding the secret. Underneath it, a row of metal connects across all of those plugs, giving you all this interconnection without any solder. I hope you can see how this is perfect for experimenting and prototyping, being able to plug in and unplug and experiment with circuits. Okay, so that's the hardware, and you get to wire up a bunch of different examples here coming up. Here's a little bit about what's called the integrated development environment for the Arduino. And you're going to follow these steps. You're going to connect the board to your PC. You install and open the Arduino IDE, then configure the board settings, which involve choosing what serial port that you're connected to, which actually will have a name as far as the USB port. Then you'll write a little bit of code, and then you press a single button that then on the IDE uploads the program to the board. So about the Arduino IDE. To install it, you need to download the appropriate version for your operating system. And there are install guides available for Windows, Linux, and Mac OS. I'll be using Mac OS and showing you how to install it on that, but they're all pretty similar. And for this course, you will use the Arduino IDE, but there is also an Arduino web editor that you can also use to program the boards. So let's go ahead and install that software. To get your copy of the Arduino IDE, you're going to go to arduino.cc with your browser. And from there, under the software pull-down menu, there's a choice for downloads. And there you'll see what I was speaking about, that there is a web editor, but that's not what you're going to use. You're going to want the Arduino IDE, and there's versions for Windows, Mac OS, and Linux, depending on what your Python setup is configured for and what operating system you're running. So I'm going to go ahead and download the Mac OS version. Great. And as I download it, I'm going to drag it into my applications folder. Once you've downloaded it, go ahead and open it up. And you should see it open up a default, what's called a sketch. That's great. Up here I can see that I'm running Arduino, and I've got a basic sketch open. In the next lesson, you'll upload your first sketch to the Arduino. You can think of it as a hello world for the Arduino. In this lesson, you'll send your first sketch to the Arduino. And just like in most programming languages, you can think of this as the hello world program for the Arduino. So to upload your first sketch, the first step is to connect the Arduino to your PC using a USB cable. Connect the A side of the USB cable to the back of your PC. Then the B side connects into the Arduino board, and on the board you should see, along with a couple other flashing LEDs, the green on LED light up, indicating that you're properly connected. Next, go ahead and start up the Arduino IDE that you installed in the last lesson. And you can close this sketch that comes up automatically. Then you're going to open the Blink example sketch, and you'll find that from the pull-down menu of File, Examples, Basics, and then you'll see Blink. Let me show you what that looks like. You'll go to File, Examples, Basics, and choose Blink. And Blink is a fairly simple sketch. It's going to change the built-in LED and set it to high, which basically turns it on. Then it waits 1 second, sets the LED to low, which turns it off, then waits another second. This all loops around, creating a blinking pattern. Next, you need to configure the board. What that means is to select the appropriate board from the Tools menu. From the Tools menu, go to Board. From here, in my case, I have an Arduino Uno, which I would click on to select. But if you have one of the other ones in this list of names, you would select it. The next configuration is to select the appropriate port that the Arduino is connected to. It should be a USB port, so look under Tools and Port, and then you'll see the name of the USB port. Okay, time to set the port. Go to Tools and Port. And here you can see the different connections that are available. I'm using the USB connection, and here you can see the number. You may want to write down what it shows there. In my case, /dev/cu.usb modem 14601. This specific address, if you will, is something that you're going to use when you connect to Python. Now, again, this will look different on your machine, but make sure that you write down what it shows next to port. And the last step is to press upload. Now that you've configured those things, you can use this check mark to verify the program. Again, this is an example program, so it's already been verified that it will compile, but that's one step that you can do. And here you can see that it says done compiling, and it shows you how much space it's going to use out of your Arduino. And then use this arrow button here, which is upload. Now when I press this, it'll send the Blink sketch to the Arduino. And it's pretty quick. There you can see it uploading, and it's done uploading already. Let me show you what it looks like on the board. When pressing upload, the L light will initially light, and then the transmit and receive LEDs will flash, indicating that it's received the sketch, and now the L LED is just blinking. Hello. All right, now that you got that working, it's time to start connecting external components to your Arduino.